This is just a method that you can use to solve a differential equation. When you write a differential equation in this form, now this is what we call a standard form for a first order linear differential equation. All right, so this is a standard form for a first order linear differential equation. Okay, so when you've written in that form, the integrating factor is just a way. In fact, the reason behind multiplying the whole equation by the integrating factor is to make the left hand into an exact derivative resulting from the product rule. All right, I've included that below here. All right, so you're actually making the left hand side in an exact derivative resulting from product rule. And then when we integrate that equation, we reverse the product rule to get what you want. Okay, so we reverse the product rule. So the idea is you get this guy called the integrating factor. He's kind of a dummy guy that you introduce in the equation to create that product rule that you'll revise when you'll be integrating that side of the equation. Okay, and I'll explain that when I'll be solving a problem. So I'll just go straight away to an example, and this will make more sense as you walk through this example. So step one is check that the equation is written in standard form. So step one, so if we can confirm that, and of course, yeah, that is true. Yeah, we've checked that this equation is written in standard form. Then we can carry on and find the integrating factor. Okay, so we can find the integrating factor now. But before you find the integrating factor, just taking you back to our steps. So the integrating factor is e to the power of p of x, all right? E to the power of p of x. So what we have to do, e to power p of x, so we have to identify p of x, and I'll include that in step 2. So step 2, find p of x. Now, if you look in our equation here, p of x is this guy here, right? So I'll just go ahead and say, well, p of x is equal to 3x squared. And then step 3, I need this dummy guy, the integrating factor. So find the integrating factor. Okay, so find the integrating factor, and we know that the integrating factor is equal to e to power integral of p of x, and p of x is 3x squared with the respect. So basically, that is our integrating factor, but now we have to simplify this, guys. All right, we have to simplify this integrating factor. So we know that we can say, but the integral of 3x squared dx will be equal to 3x cubed over 3 plus c, but we ignore c. All right, we ignore c. You don't have to write c. So this will just be equal to x cubed. So which means our integrating factor will be e to power x cubed. All right, e to power x cubed. All right, so we have the integrating factor. What next? So that brings us to step 4. We are going to multiply the differential equation by the integrating factor. So step 4, multiply the differential equation by the integrating factor. All right, so we need to multiply the differential equation by the integrating factor. So the differential equation that you're going to multiply by is this guy here. This is the guy that you're multiplying by the on both sides. You're multiplying both sides by. So basically what we'll end up with is e to power x cubed multiplied by dy over dx plus 3x squared y will be equal to e to power x cubed. I'm just showing you this so that you can know what's happening here. We are multiplying each side by this guy. All right. So we are multiplying both sides by the integrating factor, and this is the integrating factor. And then we can go further and simplify to get what we want. So basically, this will be e just simplifying this, foiling, expanding brackets. Okay, so yep, that looks good. 6x squared multiplied by e to power x cubed. All right, now I want you to pay attention to this bit. All right, pay attention to that part. Now, I don't know if you can realize, but this is a product rule calculation. All right, this is a product rule calculation. So it's a product rule calculation, but where is it coming from? All right, where is this product rule calculation coming from? Because if you find the derivative of d over dx of let me write it below here. If you find d over dx of e to power x cubed y, then that will be equal to e to power x cubed d over dx of y plus y d over dx of e to power x cubed. All right, and this will give you e to power x cubed dy over dx plus here you differentiate the power, and then so what you'll end up with is actually apply chain rule. So that will be 3x squared y e to power x cubed. Now I don't know if you can notice this, but this guy here, all right, this guy here is the same guy as that. Is exactly the same guy, all right? So that's why I said here that this is a product rule calculation. So why are we really mentioning this? So this means that, all right, what that means that, so I can say this means that the integral of e to power x cubed dy over dx, all right, in fact let me put that in little bracket, plus 3x squared y e to power x cubed, what I have there with respect to x will be equal to, now you reverse the product rule, all right, you reverse the product rule. So that will basically be equal to e to the power of x cubed y. All right. So it's like you're going the reverse way. You're going from here to there. All right. That's the reverse product rule. All right. This is what we call but the reverse product rule, or just reverse the product. Reverse the product rule. Reverse the product rule. Okay, so just reverse the product rule and you get what you want. If you differentiate, you get the other bit. You reverse the product rule, you get. So basically this will be equal to that, which will be equal to, so in our context, that will be, we know this is y multiplied by a to the power of, this was the integral, remember, of 3x squared dx, right? That's what, and which is equal to the integrating factor multiplied by y. All right. Now that is why, the reason why I'm going into all these stories here is to help you understand why after integrating here you end up with that bit. All right. This is after reversing the product rule. So after reversing the product rule, you end up to that. Okay? After reversing the product rule, you end up to that. Okay. So anyway, let's carry on with our solution now that I hope you have an idea of what's going on. I'll move on to where we were. So we were on this step. All right, we were on this step. So we had this product here, right? We had this product here. I'll just write it down here. So e to power x cubed dy over dx plus 3x squared y e to power x cubed, and this was equal to 6x squared e to power x cubed. All right, I need to check that everything is correct. Okay, so that's what we are. Now what I'm going to do is, now I'll add the next step, which will be my step 4, step 5. So step 5 will be, is it step 5? Let me check again. Yeah, step 5. So step 5 will be integrate both sides. So integrate both sides. All right. So integrate this side with respect to x, and we integrate the other side. So we'll have the integral of e to power x cubed dy over dx, and all this with respect to x anyway, plus 3x squared y e to power x cubed dx will be equal to the integral of 6x squared e to power x cubed with respect to x. All right. Now what's going to happen is, here we're going to reverse the product rule. All right, reverse the product rule. So can I just write here, reverse the product rule? We already talked about that, what it is. So what I'll end up with here, if I reverse the product rule, I'll end up with e to the power of x cubed y will be equal to the integral of 6x squared e to power x cubed dx. Now, I want us to focus on the right hand side. All right. So if you consider this bit, so for this bit, in fact, the whole of this bit, let u be equal to x cubed. I'm just trying to integrate this. Du over dx will be equal to 3x squared. Which means that dx will be equal to du over 3x squared. So basically our integral will become this will be the integral of or we can just write our so e to power x cubed, y will be the integral of 6x squared e to power u multiplied by du over 3x squared after the substitution. All right. So, and what we'll end up with is e to power x cubed y will be equal to, these guys will cancel. That goes there twice. I really don't like writing in yellow. So that will go there twice. So what we'll end up with is the integral of e to power u du, which will give us e to power x cubed y, which will be equal to 2e to power whatever u was, and u was x cubed plus c. All right, and that will be our final general solution.